Thanks, Zubir. So I have a presentation here. I've also got a little bit of a monologue that I wrote. But before I do that, Zubir wanted me to give a little context. So I've been interested in robotics since I was 11 years old, and I'm particularly interested in making robots that people can afford, or making robots in general more affordable. They're really expensive. I'll show you just real briefly this video clip. This is a robot that I have at home. It's called Rover. It's a four-wheel drive robot. It uses the same software as Skittles. So this robot, Skittles, that I made, I designed this in January, February after being invited here to ALU, and this is I designed this for ALU. So it's simpler to print, it's smaller than Rover, it's cheaper than Rover, and so it's a good classroom-style robot. But what I'm doing with Rover is I'm trying to make a genuinely good, useful robot that can go around outside, drive around a farm, and do useful things that you can make on a $500 3D printer. So this was made on a $500 3D printer at home, and so was Rover. So I'll start my presentation, and I'll try to explain why I think this is so important. Okay, so why do we build robots? Well, people have basic needs. We need food, shelter, and comfort. We need companionship, energy. We want knowledge. We want to grow. And we want love. So we need food. This person, I think, is farming rice. You know, it looks like it's some hard work, for sure. People need homes. So these people are building a shelter for somebody. All these workers also need food, of course, and they need their own shelter. And then we need clothes. So there are many people work in the garment industry in the world. The garment industry is the most human labor-intensive industry in the world because clothing is hard to automate. And there's just a lot of people. There's a lot of people, and all those people need food and shelter and clothing. There's really, really a lot of people in the world. And everybody has work that they need to do. There's so many things that we need to do. So it looks like these people are moving around some bags of rice. So if you go and you farm rice at a field, you've got to put that into a grain store somewhere, and then you've got to package it up, and then move those packages out into the world and get those into people so those people can cook that food and eat it. And we have to do this every day, day in and day out, forever. There's also just things break sometimes. So sometimes something goes awry. There's a problem, and we'll have malfunctions with things, so we need to repair things or clean up the damage that we've caused when something breaks. And then things get dirty, and we just need to clean them. So we need to pick up trash. We need to do these things. So life necessitates work. But what do robots do? Among other things, robots do work. They're really good at it. Robots are tools to help us live, and they do the work that we need to live and thrive. Robots also replace workers, so we're sort of familiar with these headlines. Automation will take 800 million jobs by 2030. Will robots take our children's jobs? Robots are coming for our jobs. Here's 5 ways to prepare. Or you will lose your job to a robot, and sooner than you think. So robots do replace workers. So the effect of robots is twofold. Robots will mean more wealth. Robots are really good at doing work, and we need work to survive. So if we can do work better, we can increase the wealth in the world. We can make ourselves all better off. But unfortunately, because of the way we distribute resources in the world, those with the robots will do really well, and for others it will mean poverty. The goal, I think, should be to spread the wealth. If we can automate things, let's all benefit from that, and let's mitigate the effects of poverty as much as we can. This is important. If it were just an engineering problem, make robots that do more of X, Y, and Z, then it would be easy. But the challenge is, how can we use this fabulous technology to help the most people? How do we make robots that give us more time with our loved ones, more food on the table, safer lives, and better medical care. This is a deeply human issue. When you look out into the world, you can see that some people have very little, and they're forced, in order to feed themselves, to live digging through trash to get what they need. This person is carrying trash out of a dump. And you see in San Francisco that this is where I'm from, and there are people living on the street in tents while other people just walk by. So here you've got people living, and this guy is just a nice, well-dressed guy. He's real happy going off somewhere. But for me personally, it doesn't make any sense. I'm so lucky that I was born in California, that my father was an engineer, that my grandfather was vice president of an alcohol company in America, and he was able to send me to a good school. But there's nothing about me that makes me worth the fact that I can pay for shelter and these people can't. And I see that robots don't care who you are. We can make machines that just produce enough for everybody. I'd really like to see robots that, pick up after us and maybe go and do some deep sea diving and some really fantastic things. But I'll get more specific. I'll read the thing that I've prepared. So I showed you the 3D printed robots that I've been working on. So at a first pass, zeroth order, I'm trying to make better 3D printed robots. I'm constantly, fanatically working on 3D printed robots. I've been into robots since I was 11 and building things since I was 5. And now I work in Silicon Valley and I have a nice career in robotics. But when I go home, in the evenings and on weekends, and even with not uncommon protests from my partners, I'm working on robots. The goal is not just to print robots for fun. Yes, printing robots is fabulously fun. And I do want to preach and evangelize the wonders of making robots at home. When you have an idea and a month or 3 later, you see the thing alive and moving around, expressing itself, it's extremely rewarding. But it's hard too. You find yourself dedicated and staying up late till 3 or 4 a.m. before heading to work the next day. You lose sleep and you stress, and it can be hard. I keep going because I think there are broader implications to 3D printed robots. More deeply, my goal is to enable people anywhere in the world to start up their own local manufacturing center. And I want to help those people make economically productive robots right in their shop or home. When you can manufacture something yourself, you can change it to fit your needs. The thing better serves you. The world will, I predict, by and large, provide a highly centralized model for distribution of robotics technology as it develops. The Googles and the Samsungs and all the other big technology companies from all over will use their wealth to produce fantastic robots capable of hugely productive work. But they will also charge a great deal for those robots. Billions will be unable to benefit directly from these technologies. The big companies will lease their robots with license fees just cheaper than human workers. And local businesses will pay indefinitely for the machines that allow them to compete just a little better than before. The explosion of wealth promised by robots will not go to those leasing the machines, but to those producing them. The global population will pay what they can for the improvements the machines provide. Their lives truly will be better by many measures, but they will not own the machines to fix and change and modify as they see fit. I see a vision for the future instead, where little towns all over the world have places where local vendors are printing, assembling, upgrading, and selling robots to their local population. Instead of Samsung manufacturing a robot in Asia and shipping it to a little town, bringing the profits back to Samsung's already wealthy holdings, local vendors would work hard to make robots that are just what the vendors need. When the local farmer takes their hard-earned savings and decides to buy a robot, the local vendor gets wealthier and becomes a little better able to support the farmers. The vendors in turn take their wealth to buy more food from the farmers, and in this way, the robots help improve everyone's lives. Too often, we see stories of workers abused by their employers. In 2013, riots broke out in Little India, Singapore, when a bus collided with and killed a migrant worker. The local companies had been hiring these workers, but paying less than what they had agreed. And if a worker got injured, they'd be kidnapped by the employer, forced to sign documents they were not permitted to read, and sent back to their home country with no say in the matter. The law requires that these companies pay the medical bills of the injured workers, but instead the workers were shut out and sent away. The workers had no power to negotiate. They were at the whim of the employers. They only had freedom as long as they were useful. I dislike this treatment of people as small cogs in a giant machine, as disposable laborers to be utilized until they're worn out and then discarded. It's inhumane. I see no reason why some people should be left in a situation where they choose the destruction of their own bodies in order to survive. And this is something I see robots being able to eliminate. Right now, workers are people. And so, in order to meet the needs of one group of people, another group of people has to work. And the first group wants the second group to behave like machines. Well, we are not machines. We are human. Let the businesses have their machines. Let them build empires. We will take the shops they build and the factories they create and use those to produce technology that frees the laboring class from their toil. Machines that help farmers harvest. Machines to transport goods between towns and cities. Roads and aqueduct building equipment. And when you have roads and water and a roof, we will make machines that make high-quality stoves that vent away from the kitchen so you can save your lungs. And when you have a machine that makes houses and stoves and you can breathe better, we will make machines that wash your clothes for you and cook your food for you. And we will make machines that make those machines. Instead of working outdoors where your feet hurt, you can work indoors and make improvements to the machines. Instead of working 12-hour days, you can work 6. When there is a sunset, you can stop and enjoy it, because you will still eat even if you're not working constantly. Once all this is underway, I hope to see a world where no one wants for food. The world is large, and I do not believe that all of the machines that produce everything we need can come from Asia. The buildings that help the farmers can come from the builders who live in the towns where they're used. The farmers can see how those machines can be improved. They can make the changes needed, and they can print the upgrades as needed. When they do, they'll share the knowledge they have learned freely with everyone else on the internet. The machine builder in the local town in Bangladesh is not competing with the machine builder in a town in Kenya. They are brothers and sisters in a global network of hackers who want to see the world around them improve. I see that the way to get food in every mouth is not to beg the wealthy to send food to everyone. The cost would be enormous and many people would be missed. Even if we took on such an endeavor, the destruction of the environment would be accelerated by the constant flights of jumbo jets from the fields to the hungry mouths. Brussels and Beijing cannot support the world from afar, nor would everyone appreciate the effort. Instead, we must work to share the knowledge of what we have. The robots we build in San Francisco will not be the same robots that are needed to rebuild the shattered cities in Yemen, but the insight we gain can be shared. We needn't export robots that people don't need, but knowledge that can be repurposed. In this way, the people with great wealth who spend their days making robots to deliver smoothies to my desk can still help those who want to build better robots and larger farms. The wealth of the few is not mere things, but knowledge, and we can build a world that refuses to put up barriers to help others. When we learn to make a cheaper or better robot, we can share that with others so they too can make machines that help their people. This will take participation the world over to accomplish. We need a global movement of engineers and builders and users who work together to build, use, improve, and share machines that make the lives of all people better. When the cities become automated and the workers are sent away, let's give those workers a new place for their skills to be used. The engineers in the wealthy places can search the world for new, better ways of moving motors, sensing the world and solving problems. And those in the small towns can work online with the engineers in the cities to try out new ideas, see what works and what doesn't, give their own feedback on modifications and upgrades. The machine builders can work to find customers and understand their needs, to take the human problem and convert that into a plan of action for the engineers. This will help the others to drive a global population of hackers to find new and better ways to solve problems. And we can put the massive wealth of this world to the task of helping us all. So that's a really sort of a lovely, beautiful, grand vision for things. And I can understand very justifiably how it might not sound realistic, but I wanted to give one example of what I mean something I've seen happening in the real world that really represents what I'm talking about. So this lovely article from 2012 says Stratasys. Now, Stratasys is a company that makes commercial industrial 3D printers. And this article says, Stratasys celebrates the 10-year anniversary of the industry's first low-price 3D printer, the Dimension. And if you look here on the text on the right, when introduced in 2002 at $29,900, the Dimension 3D printer opened new possibilities for designers as a reliable, compact, simple-to-use machine at about half the cost of the next lowest-priced 3D printer. Well, that was in 2012, or it was introduced in 2002. It looks like this. This was an industrial professional 3D printer. And in 2012, they were still patting themselves on the back for it. But at the same time that Stratasys was talking about how great it was that they introduced this low-cost $30,000 3D printer, the patents had expired a few years before, and there were hackers out in the world designing their own 3D printers that cost about $700. And they were totally open source. These people who figured out how to make these things shared the designs online for free. They just wanted to help other people make this stuff. And so this printer, which was a printer from around 2012 when that article was published, could print its own pieces. If your friend had one, they could print you all the parts that you couldn't buy at the hardware store. So then they print you those parts, you buy the rest in the hardware store, a few electronics from the internet, you put it together, now you've got a 3D printer too. Those 3D printers print really high quality parts. And so that was back in 2012. That was circa 2012. That's the Prusa Mendel. Well, now the Prusa i3 Mark III, this printer here, I've talked about it already a few times. I love this printer. This just came out in October, I believe. It's from Europe. You can buy it as a kit for $750 or totally assembled, calibrated, and tested for $1,000. And this thing is really great. It's completely open source. So all the design files were available as soon as this thing came out. And despite you being able to just download all the files and make it yourself, they've sold 7,000 of these printers so far. Not just sold, but shipped 7,000 of these printers so far. That's $7 million of open source robots that are being sold and shipped all over the world. This is Joseph Prusa. These are all of his printers. He's got a tattoo for open source hardware. That's that little gear logo. And this is actually an older shot of his print farm. The print farm now is much larger. They've got hundreds of printers operating full time, printing all the little orange parts that you see as part of that printer. And he's got 200 employees now who are helping put this vision together. So when I talk about making open source robots you can make at home, I'm talking about dramatically lowering the cost of robots in the same way that Joseph Prusa and all the other hackers in the 3D printing community dramatically lowered the cost of 3D printers from $30,000 to $1,000. And the robots that are going to drive around and do farming in the world and are going to do your local manufacturing and all these other things, if you buy them from the Samsung or Google or these other companies, they're going to be very expensive. But just as was done with 3D printers, I believe strongly it's possible to do it with robots like Skittles and Rover and all the new robots that we can come up with. I love using 3D printers because any person can operate them. You can download the files for free. It's a really great medium for doing things. But I'd like to see a world where people everywhere are working together just to help people make what they need. Thank you.
Cool. Thanks, everyone, for this. So if you have any questions about what the vision was about, do a short Q&A, and then if you're interested, you can do a demo on what Skittles can do for now.
Yeah. I'll let it beat up.
Yes.
Yeah.
So I have a question about how you envision powering robots at the scale that your ambition is.
How to provide them the electrical power, the motive power? Yeah. Well, I think lithium batteries are a really fabulous technology. The battery on Skittles was I think that was a $12 battery or something like that. So they're relatively affordable. I will say that this robot still costs about $400. So it's still expensive. And the robot rover that I'm building is about $1,200. So it's expensive. I would argue that, if I finish rover, it will still be about $1,200, but it will hopefully provide as much value as maybe a commercial robot that would cost $10,000 or more. So it's lowering the cost, but robots still are expensive, and we need to keep working on lowering that price. But lithium batteries, I think, are really good for this, and solar power to charge them up. Yeah.
So I think recently I read an article, I think yesterday, from the World Economic Forum, that Walmart patented development of miniaturized bees. Just imagine our bees that we have now at 28 flowers, but now imagine a swarm of bees, but in form of robots.
Yeah.
So with this vision of making, custom, robots like from home.
Yeah.
What are the drawbacks in terms of the context of the food chain? Just imagine a bird is flying around and hungry, maybe you think it's a bee.
Yeah.
Then otherwise it's a robotic bee.
Yeah.
So what are the drawbacks in terms of the environmental challenges that can affect the food chain?
Yeah, that's a good question. Well, I suppose with anything that we're manufacturing, there's a certain amount of waste involved just in the manufacture of something, and then also as it wears out and breaks, if you can't repair it, you have to throw it away. So one thing that I really like about the 3D printed stuff is that the motors on Skittles will last forever, but maybe the gears will wear out, or maybe the frame will break. And because the files are freely available online, I've got a website, you can download them, then if you have your own Skittles and it breaks, you can download the parts and print it. So one of the environmental impacts of sort of do-it-yourself open source hardware is it's easier to fix. It's easier to make it last longer. So you hopefully have less stuff being thrown into landfills. Now, as far as these actual robotic bees, that's a tricky one. I've driven this around the island a little bit, and the dogs look at it quite confused, and they just sort of keep their distance. So none of them are going to confuse this for something that they should eat. And I suppose if they went up and tried to chew on it, they wouldn't get too far before they just got tired of it. But making a lot of a high volume of small machines, they'll eventually end up as waste, and that is a real concern. So the more we can figure out ways to recycle things when they wear out, and not just leave them scattered around the environment, like I could imagine these bees, the better off we'd be.
Is the open source software side as caught up with the hardware side as far as the design?
Well, so that's a good question. Certainly the 3D printer uses, so the Prusa printer here, for example, uses open source firmware that runs on the printer. But the design software, open source design software is still pretty limited. So there's a program called OpenSCAD, which is a way to design parts by sort of writing some code. But I really don't like that method of doing things. So I use Onshape, which is not open source, but it is free for anyone to use. And I like, because it runs on the browser, I can use it in Linux, a free operating system. So Onshape is sort of the best I've found. But what I'd really like to find is some sort of a free alternative to Onshape. But unfortunately, we're not really there yet. Yeah. Oh, and when I say a free alternative to Onshape, I mean free as in freedom, not free as in beer. There's all this term, you go to a party and somebody will give you a free beer if you want, but it doesn't cost you any money. But then there's free as in freedom, meaning you have the freedom to change it. So there's a term called free software that's a little bit different than just software that doesn't cost any money. Yeah.
So you said you have 3D printer at home, right?
Yeah, I have 4.
And you printed most of the parts you use.
Yeah.
So what takes up most of the cost? Is it the printed powder that's the right shape, or the electronics that's involved?
Yeah. So the robot uses the 3D printer uses a plastic filament. So it's sort of like a long noodle of plastic. And so for this robot here for Skittles, this is maybe about a kilogram of plastic, so about $25 US worth of plastic. And the electronics here are about $300. So the plastic is much cheaper than the electronics. And the biggest cost is these two motor controllers. They're each $100. And that's from China, so you're getting sort of already the lower cost out of it. You can buy these from US vendors and they're $150. So $100 is sort of the low price for this part. I'm working on designing some that I'll sell for a little cheaper, and they'll be totally open source. So I'll sell them maybe for $80, and I'm hoping that I'll get some Chinese vendors to clone my product and sell it for even cheaper. So, but that's one of the more expensive parts of robots right now, especially this kind. Yeah. Yeah. I also brought a few sort of little demo pieces here. So Skittles uses a planetary gearbox. It's a special arrangement of gears that is very strong and compact. And I made a version that has actually 3 of those all stuck together inside here. So each one goes 5 times slower than the last one. So when the motor on Skittles spins, the wheel spins 5 times slower. And so when there's a motor inside here, and then there's 3 stages of gears. The first stage is a 5-to-1 reduction. It's actually a 5 1/4 to 1 reduction, but let's just say 5. So it's a 5-to-1 reduction. Now the second stage is another 5-to-1 reduction, and so is the third stage. So the motor gets slowed down 5x, and then that gets slowed down 5x. So that's 25x slower than the motor. And then that gets slowed down 5x again. So that's 125x slower than the motor. So it's slower, but it also has 125x the torque. So every time it goes slower, it's also puts out more rotational force. And as a demonstration of this at home, I printed this little lever arm coming off of it. This is a 160 millimeter baseline here. And then I started hanging weights off of it just to see what it would do, just to see how strong it was. And when I started rotating this motor, it picked up a 5-pound weight, no problem. So then I put a 15-pound weight on it. It's about a little under 8 kilos. And was hanging that off of here. And this will happily rotate while hanging this decently heavy weight off of it. I was pretty impressed that it didn't break. And it didn't really break a sweat. It didn't slow down as it was moving. And it was both happy to lift the weight, and then it was happy to lower the weight at an even rate without sort of sagging or anything. So this is a bigger 3D printed gearbox. If you really want a lot of torque, so you might have some machine, or maybe this is doing the steering on some bigger, really big robot. This is what the inside of the Skittles gearbox looks like. So there's a motor here, and then there's a little gear right there. And it has 3 of these little gears on the inside. And those 3 gears sit inside the housing like that. And as this rotates, you get a gear reduction out of it. And so these simple parts are printed on the printer at home, and they make that gear reduction. And that means that the gear reduction is important because it means you get enough. Slight meltdown. The gear reduction is important because it means that you convert the power of the motor into something that you can use. And then I've got a box of some other really interesting parts. This was 3D printed on a $30,000 printer. So it's a really high quality, clear looking part. I'll leave this box of parts over here when we all get up, and I'm happy to talk a little more about these pieces. But there are still really high-end printers that do way more than what you can do at home. That old $30,000 printer was doing the same thing as these $1,000 printers do now, but there's still cutting-edge technology that does some pretty impressive stuff. So I'm excited for when that stuff also becomes $1,000. And then I'll give you a demonstration of Skittles. I've had a little trouble with this remote, so hopefully it works. Yeah, there we go. So right now Skittles is remote control, but it's running all of its programs in Python on a Linux computer or Raspberry Pi that runs on the robot. So the students that are working with me and Zubir on the robotics class are learning how to program this to be able to do different kinds of automated movement. So the remote control just helps you drive it around and see how it works. It's got this interesting little tail to it. And people have asked, why didn't you use a wheel there? And you totally could use a wheel. But I just wanted to see what would happen if you used something even simpler, just a hook. And it works surprisingly well. Even when it's backing up over rough terrain outdoors, that little hook works just fine. So all of Skittles is totally open source. I don't try to protect any of my intellectual property. So there's this whole notion that if you make something, now you get to tell everyone what they can do with it. And when I talk about making all these robots, if you just want to help everybody as much as possible, then I think one of the best things you can do is just don't try to exercise your intellectual property rights. Just make it open source. Intellectual property rights are invented by governments as some notion to protect printing press or people running printing presses. And in a world where we could just share our information for free and help other people, I see that as just better. And so while I don't expect that we'll ever end the legal practice of intellectual property, you can just open source your stuff and opt out of all of it. And same goes with patents. If you patent something like Stratasys did with their printers, then what you're going to end up with is things being very expensive and only having a single supplier. But if you just give your designs away for free and let people do whatever they want with them, then you can really help. You can really help people. Thank you. Yeah.
On that note,
Yeah.
In terms of the number of parts you're printing, how many of those are designed from scratch on your side, and how many of them are doing modifications on existing designs?
Yeah, so for Skittles, for example, the planetary gearbox came from a script that Onshape, I think an employee of Onshape made and shared on their platform. So that generates the raw geometry of the planetary gearbox. And then I built the actual functional geometry of the gearbox off of that. All the other mechanical stuff I designed myself. Yeah.
Well, thanks a lot, guys, for coming. We'll leave this box here for a few minutes, so you can come and dig through it. And if you want to play a game, you can just guess which parts and which ones are not. Some of them are, some of them are not. But yeah, thanks a lot.
Thank you.